So for example 1 here, um, you're being asked to solve a system of equations and by graphing and by an algebraic solution. Now, you're not going to be able to really do or show me any work you do on a graph, but I'll give you some time to pause and to determine what the algebraic solution is, and let me know what the solution to this system of equations would be. So graphing, one thing you'd have to do is, the easiest way to graph them is to put them into slope-intercept form and then graph them. And as you can see, I graphed the two lines, and I see that there is a solution which looks to be somewhere around 2, 4. One of the things about graphing is, I mean, first of all, you're not always going to get solutions that have integer answers. I mean, a good number of them will very well be, but you're not guaranteed to have them. And when you get situations where you have one or both answers not being an integer, that can be difficult to do with graphing, depending on how you have things scaled. So algebraic solutions are much more ideal. And up to this point, all we've really been looking at is substitution. So one way we could, I mean, since I do have both equations solved for y at this point, I could set 3x minus 2 equal to negative 2/3 x plus 16/3. However, what I could also do is just like look at one of them in its slope-intercept form and one in its expanded form, which is the one I'm going to show here, and solve that way. So you notice I'm keeping the top one as the y equals 3x minus 2, and I'm leaving 2x plus 3y equals 16 kind of where it is. And I chose that mostly because of the fact that the second one had much more fractions. And even I don't shy away from fractions, but if I recognize that one has integers and the other one doesn't, I'm going to go with the one that has integers because they're usually easier to work with in the long run. So if you look that far enough ahead, you can make such adjustments. So what you're seeing me do here is, since I know y is the same thing as 3x minus 2, I'm going to the equation, the second equation, and I'm replacing y with 3x minus 2 since they are equal to the same thing. So simplifying the left-hand side, I get 2x plus 9x minus 6 equaling 16. Combine some like terms, I get 11x minus 6 equaling 16. And then adding 6 to both sides, I get 11x equals 22. And dividing both sides by 11, x equals 2. Now that's part of the solution because I had to find a solution for the x and the y. So now that I have this solution, and I do have one equation at the very least solved for y, I'm just going to plug that x back into the y equals 3x minus 2. And I do find that the y does equal 4. So the solution is 2, 4, which looked like that's what the graph was originally. But as I said, just because it looks like it passes through integers doesn't mean it actually is. I mean, if you get an integer answer, you get an integer ordered pairs, plug them in, make sure it works for both, and then you're good. But if you find that doesn't work, you may have to do algebra to get the exact answers.